Okay, scale diagrams. So great white sharks can grow to a length of approximately 16.5 meters. So that's roughly about 20 feet. The diagram is a scale drawing of a great white shark. So to determine the actual length, if this was the scale diagram, to determine the actual length of the shark, we would need to know what the scale was used in the diagram. So a scale can be written in a couple of different ways. I can write it as a statement. 1 centimeter on the drawing represents half a meter in real life. So 1 centimeter represents 0.5. Or I can write it as a rate. 1 centimeter is to 0.5 meters. Okay? Or I can put it as a ratio. When I write it as a ratio, remember ratios don't have units. So I have to choose a common unit. So I can't go 1 to 0.5. I have to go 1 to 50. 1 centimeter to 50 centimeters. Or I can put it as a line graph scale. This is what you see a lot on maps. Or if you're flipping through a book and they show you a scale drawing of a map, they will have one of these. And this is showing you again, 1 centimeter is equal to 0.5 of a meter. Okay? So, the lengths of sharks are generally measured from the tip of the nose to the middle of the tail. So from the tip of the nose to the middle of the tail. I want to change the color so we can see. So if I drew a line, or if I measured from the tip of the tail to the middle, or sorry, the tip of the nose to the middle of the tail, what did you get for the length? You guys have rulers, so what did you get?
9.5 centimeters.
9.5 centimeters. Okay, 9.5. Did anybody get something different? So the drawing was 9.5 centimeters. What I want to know is I want to know what the actual is. So if the drawing is 9.5, what is the actual? And then in order to complete this, I need that scale diagram. And that scale diagram told me that 1 centimeter on the diagram was equivalent to what? Half a meter. So I can use proportions to set these up. And then I can cross multiply. 1 times x is x. 9.5 times 0.5.
4.75.
And what are my units that I use?
Meters.
Meters. And that's because this is on the bottom. The bottom represents my meters. So the shark is 4.75 meters long. Okay? Map of Alberta. So if I look at the bottom of the map, there's my scale. What is my scale showing? What is the length of each of these increments?
11 centimeters.
Dylan?
11 centimeters.
So 1 centimeter is equivalent to what?
75 kilometers.
75 kilometers. So if I look at the question is, determine the approximate straight line distance between Calgary and Edmonton. So if I go from Edmonton, which is the open circle, to Calgary, and again, I will change this so that we can see it better. There's my straight line distance. What is the length of that line?
5.8 centimeters. 4 centimeters. Oh wait, maybe I was looking at the wrong one. Yep, I had my ruler in the wrong one. Yeah.
So when you measured it, what did you get, Mitchell? 3.9, 4. Anybody else want to weigh in on this? Anybody get something different?
I got 4.1.
Oh my god.
So 3.9, 4, 4.1. Let's just pick 4. So my drawing is 4 centimeters. And then I have to my actual, which is what I'm trying to calculate. The scale is that 1 centimeter is equivalent to how much?
75.
75 kilometers. So if I cross multiply, 1 times x is x, and 4 times 75 is
300
300 what?
kilometers.
Kilometers. Is that the approximate distance between Edmonton and Calgary? Yeah. Okay, let's look at another map. Map of BC. What's the scale this time?
Centimeter equals 100 kilometers.
Thank you. 1 centimeters, 100 kilometers. So I need to find the approximate straight line distance between New Hazelton and Prince George. Here's New Hazelton. And Prince George is right here. So straight line distance. There's my line.
3.5.
3.5. Do we agree with Matt?
Yeah.
Okay. So the drawing was 3.5 to the actual, which is what I'm trying to figure out. And 1 centimeter is equivalent to 100 kilometers. So what's the straight line distance?
350 kilometers.
Okay. Is this realistic to the driving distance?
No.
No, because the driving distance is actually this. You have to go through Smithers, through Houston, Burns Lake, Fraser Lake, Vanderhoof, and then Prince George. So what could I do to get a more accurate measurement
Drive it.
other than driving it?
Measure the road.
Measure the road, but the road isn't really straight, so how could I straighten this up? Could I measure between 2 points?
Yeah.
Okay, what would be my first point? New Hazelton to where? Where?
Smithers? Yeah. I think that's what it says.
So would you do straight line to all of these different towns?
I'd go Hazelton and Houston.
New Hazelton to Houston, does that look like a fairly straight line?
Oui.
Okay. And then from Houston to where? Could I go kind of almost straight to Prince George at that point? Would that be a little bit better, more accurate? Okay. So I could go from New Hazelton to Houston, and then Houston to Prince George. So that's why if you're Google searching stuff, and you're Google searching the distance between two places, a lot of times Google Maps will give you driving distance, and they'll also give you straight line or a flying distance, because they're not the same. Okay, a couple more examples on scale diagrams. Tyler's scale diagram of a tower is shown. The actual tower is 240 meters tall. So we're going to figure out the scale that he used. So when you're doing scales, scales are always done the same way. Always the drawing to the actual. So in actual fact, my tower is 240 meters tall. If I measure it with my ruler, what is the height of the tower?
8 centimeters. From the tip, yeah.
When I'm writing a scale diagram, my drawing is always reduced down to 1. When I'm reducing, when I'm enlarging, it's a little bit different. So if I divide top and bottom by 8, 8 divided by 8 is 1. What's 240 divided by 8?
30.
How much?
30.
So this is 1 centimeter to 30 meters. So as a statement, 1 centimeter represents 30 meters. If I write it as a rate, 1 centimeter is to 30 meters. What happens when I go to write it as a ratio?
You have no centimeters or meters, it's just straight up numbers.
Straight up numbers. So I need to have common units. So I need to convert my 30 meters to centimeters. How do I do that? Times it by 100. Which gives me 3,000 centimeters. So then my ratio becomes 1 to 3,000. Okay, one more example. Kylie from Abstract Renovations designs a plan for a candy store. The scale diagram is 1 centimeter is to 50 centimeters. What are the actual dimensions if on the scale diagram they're 8 by 12? 8 centimeters by 12 centimeters. So I have 1 centimeter is to 50 centimeters. So 8 centimeters is equal to what? What would I do?
You go 8 times 50.
And what's 8 times 50?
400.
So 400 centimeters, is that how I would put it on the plans?
There's 4 meters.
I'd put it as 4 meters. Okay. And then I have my 12 centimeters. 12. And I'll just use Y for the different length.
600.
And would I leave it as 600 centimeters?
6 meters.
6 meters. Okay. If I go backwards, if I have the chocolate section of the store and I'm expanding it to be 3.5 meters by 4.75 meters, I still have my 1 to 50. But what do I have to do to these units in order to put them in the scale diagram?
Times it by 100.
To change them into centimeters. So if I multiply by 100, what do you get?
360.
And
475.
so the drawing is what I'm trying to find this time, and I have the actual. So then when I go to cross multiply, I get 50x equals 350, so then I would divide. And x would equal
7.
and then the same thing with the 475. So I'm going to give you a minute. I want you to do the 475 on your own. So when I set up my proportion, 1 is to 50 as y is to 475, cross multiply, 50y equals 475, divide by 50, and I get 9.5 centimeters. So the dimensions of the chocolate section on the drawing would be 7 centimeters by 9.5 centimeters.